Hello, I'm going to continue talking about the binary tree. Like I said previously, we have grammar rules in a programming language, and those grammar rules are used to produce either a binary tree or other kinds of production strings, like I'm going to show you later. Like this, we need the first rule that produces this binary tree from S starts terminal to A. We could use that rule, or from A to A, we could use that rule here, and from A to A, we could use, again number 2. So we could use any rule to create this binary tree. Like, but binary tree is not the only thing we could use to build the binary tree out of the grammar rule. We can also use like a grammar production. And the grammar production is just combining all those rules to create a string of production. Like it starts at the start terminal and goes to the non-terminal A and the string, and from here that A from here becomes this, the string A and the non-terminal symbol combined with the string. So that will be A, the non-terminal A and the string A. If you see how I got from here to here, it's just a combination of the first one and the second rule. And then if I go again, the next step, if I could use maybe the second rule again, it will become A non-terminal with a small a with another A. Basically, I think I'm missing extra A. Basically, this A becomes that term right here. This is the same term right here. It became because of this second rule. And this whole thing is called the grammar production. And you could translate from grammar production to the binary tree production as well, because you are producing a tree out of it. So yeah, like I talked about earlier, there's little a is just a string which is concatenated with a non-terminal A. And rules have names too. Rules can be named big G. And just like in mathematics, we use letters to name things. Like G is just the grammar rule. And L, the function f or g, is denoted as grammar production. Which is, this is the grammar production, and G. So anyway, and like I'm going to talk more about how the tree is related to the grammar rules. Like if you know anything about binary tree is usually the combination of vertex or nodes and edges. So that will be nodes, that will be in edges. And how is it related to the grammar rules? Where, like, for example, a string A, like in this um, example that we did, we've noticed that little a, it's always the leaf of a tree. Little a is always the leaf. So, and you also notice that the non-terminal, it's also a node, but is a different kind of node compared to little a nodes, because the non-terminal we're still going to produce more characters, more strings, which is why it's not like the nodes, the last nodes, even though it's still a child in a binary tree, but it's also a parent. So a non-terminal, you can say the characteristic of a non-terminal, it could be a parent and a child at the same time. Whereas a string can only be a child because it is a node. So anyway, so next time I'm going to talk more about ambiguity, which is more related to leftmost tree as, as well as rightmost tree. See you later.